We'll give Peter an opportunity, if we can get his sound working, to speak in just a few moments. Before we do go any further, I want to talk about a few logistics. Today's TechCast is being recorded, and a link to the recording will be made available to all attendees within the next few days. If you have any questions throughout the TechCast, please submit them via the console. We will run through these at the end of the presentation during the Q&A session, and if time permits, we will take some live questions as well. We do have a hot stop at the top of the hour, so any unanswered questions will be answered after the TechCast by email. To facilitate that, we suggest that you do include your email address when you submit the question over the console. I also want to take a few moments to talk to you about us, the International Sybase User Group, for those of you who don't know much about us. These TechCasts are brought to our members free of charge as part of the benefits offered by our organization. We would like to welcome the new members who have joined the group in order to attend today's TechCast. We encourage all of our associate members here today to visit our website, www.isug.com, to learn more about us and what we do, and to consider upgrading to a full membership. ISUG is an independent organization that exists solely through the financial support of our members and our partners, such as Mlogica. Our membership fees start at just $25 a year, depending upon your location. Those of you that upgrade to our Green and Gold memberships will receive, among other things, a subscription to the ISUG Technical Journal. This is published monthly in electronic format and contains technical articles related to the use of Sybase software, along with some pieces on more general IT architecture and strategy. We do also put out a print version of that magazine once a quarter. We'll be sending out some additional information about ISUG after today's presentation, so please do watch for that in your inbox. And now, without further ado, let's move forward to today's feature presentation. It's my pleasure once again today to introduce Jeff Garbus, who's going to give us a presentation on single table optimization within ASE, otherwise known as All About Indexes. Jeff has over 20 years of hands-on expertise in architecture, tuning, and administration of Sybase ASE databases, with an emphasis on assisting clients in migrating from existing systems to the latest versions. Jeff, if you're ready, over to you.
I am ready. Looks like they've just made me the presenter on this, so let me take a moment and open it up and see if I can get things rolling on my side. Okay, Mike, can you see the presentation?
Yes, Ken.
Excellent, then we should be ready to rock. Hello, everybody. I am Jeff Garbus, and I would like to invite you as we go to just jump on in and ask questions if they come up. If I don't notice them, hopefully Mike will prod me and say, hey, Jeff, you have a question up there. You need to answer it. We've done the introductions. We're skipping past Peter's stuff, and we're going to let him have an opportunity at the end to talk about the relationship between Mlogica and ISUG, as well as all the cool services that we provide, from managed services to business intelligence and staffing. My own background, I've been working with Sybase for about 20 years now. I'm up to 16 or 17 books on Sybase Server. The longer you've been in this industry, the more likely you are to have one of my old books lying on your desk someplace. Agenda for today. The material that we're going to cover is material that I will generally cover in about 2 hours in an ASE performance and tuning class. What this means to you is I'm going to be talking relatively fast, and if there are topics that you'd like to see covered, my recommendation is that you simply slow me down by raising your hand and asking a question. Topic list is here. Rather than read it to you, I'm simply going to dive in because our time is limited. When we talk about single table optimization, what we're really talking about is index selection, and we're going to be talking about everything from the physical aspects of the indexes to how we select indexes and how the optimizer selects indexes. Note that the optimizer's ability to select indexes and the types of joins the optimizer can do have changed with 15. The optimizer's join selections will be probably the topic of another one of these webinars at some point in the future. For now, we're just talking about how we get the information out of a single table at a single point in time. So ASC has about 3 basic search techniques that we use to get the data from a database table. The first is a table scan. The idea behind a table scan is that we start from the beginning of a page chain. We look up the first page in the page chain. We read the information from the page chain. Once we've read the information from the page, we check the header. The header will point us to the next page in the page chain. Once we have that next page in the page chain, we read it, and we keep going until the next page in the page chain is null. That's what a table scan is. We read every page which is associated with that particular table. We retrieve the data. The next type of search technique the server uses is an index search. The idea behind an index search is that we can get to the data a little bit more quickly. If we've got, 500 million rows of data, then our average search to retrieve a random row is 250,000 reads to get there. Well, we don't want to read through 250,000 rows every time we're looking for a particular row. We want to get there faster. ASC does use B-tree type indexes, and we will even be looking at physical structures of the B-tree type indexes as we're going through this talk. And finally, there's a thing called a covered index search. A covered index search is a slightly different animal, and we'll do this graphically when we get to the example. But the short version is that rather than going after the data page itself, we have all the information we need in the index. So we pull the information from the index and continue. So that said, a table scan is the way the server resolves the query if, in fact, that's the only way to get the data back. Table scans are, by definition, expensive because we're reading every page involved. Note that the table scan may be planned even if the rest of the query is false. If you say, for example, select from the table where 1 is equal to 2, we know that 1 is not equal to 2, even those of you who have just had lunch and are ready for a nap like I am. But the server is smart enough to identify these types of situations and short-circuit them. So you may run a show plan on something like this and see that it plans a table scan, but when you set something like statistics.io on, you find that your cost is 0. Here's some output using the newer tools that are available to us. And we're simply identifying that the cost of the table scan for this is zip, even though we are planning a table scan. This is the new output, by the way, for those of you who have not seen. I wish I had a good way to do a survey. If I were in a room, I'd ask everybody to raise your hand. If you're on 15, you may have already seen this type of output. This is the new show plan output for 15. Tells us here that we are planning a table scan. For those of you who aren't familiar with show plan output, I'll take just a couple of seconds and point out that what we're looking at is the type of select statement that was run. The note that the type of activity that it's selecting is table scan from the PTTX table. The type of scan, which is forward, versus backward, which is another opportunity. We're saying we're positioning at the start of the table using I/O size of 16K. The I/O size of 16K is an indicator, if we're using 2K pages, that we're using a large block I/O, which is a good thing. If we're using 16K pages, the 16K I/O is not so good. It might be an indicator that we have something odd going on. LRU buffer replacement strategy is saying we are going to age out the least recently used page, which is the normal way we will age things out within cache. There's 3604 and 32 output. I'm not going to go through all the output here because we've got about 90 slides to go through in about another 30-35 minutes. Note that it's not just the select statement that may plan a table scan. Here we have an update statement. The update statement can also plan the table scan. Here we're saying update the table, set ID equal to ID plus 1. Let's presume for a second that we do not have a unique ID, an identifier on that. Well, guess what? Because we're modifying all the IDs, we don't have a where clause, we're going to do a table scan in order to get this resolved. For those of you who are interested, note also that you have the capability of running this particular SQL statement even if you do have a unique index on ID, because the server will do a deferred update and it will allow you to go from 123 to 234.